Hello, class. My name is Shane Collins, and today I will be presenting about marine sediment cores. This image is sourced from Integrated Ocean Drilling Program. Right there, those are the cores, actually. What are marine sediment cores? I'm so glad you asked. Marine sediment cores are pieces of sediment that are extracted from a body of water, and they take a boat out and take a tube, sending it deep underwater and underground to collect sediment. If you don't know what sediment is, it's pretty much, I mean, it's not dirt, but it's pretty much like dirt. For the layman, um, the sediment can be over 100 million years old. And I got that from Lamont Doherty Core Repository. The sediment we will be talking about today is much younger, but I found that fact to be very interesting. The sediment found is called a marine sediment core, and it can be used as a lens into the past, telling us about past climate change and much more. And the image is a sediment core being brought up alongside a ship from Lamont Doherty Earth Observatory. And here's a map. So the two locations we will be focusing on today are it's the Pearl River estuary on the left in China in the Guangdong province, and the other one is Beppu Bay in Japan, which is southwest, yes. And the Pearl River estuary is in southern China. And the images or location of Pearl River estuary, November 2022. And other one is Beppu, the most geothermal city in the world. Wonderful Japan. Pearl River estuary, southern China. As you can see, that's the estuary right there. The image, Pearl River estuary, 18th of February, Ocean Color Image Gallery, NASA. But yeah, so scientists use a continuous deposited sediment core in the Pearl River Delta, more specifically, the Pearl River estuary in the Macau Sea. They were dating the sediment using lead and cesium isotope dating methods. They dated sediments from four different time periods: before 1950 to 1950, 1950 to 1976, 1976 to 2000, 2000 to present, which at the time was 2022. They found that the amount of toxic metals such as lead found in the sediment lined up with human development at the time, with pre to 1950 having low heavy metals because it was more agricultural time. From 1950 to 1976, it increased and there was steel processing in the area at the time. Then it decreased around 1976, and then increased in 1980, followed by a decrease, an eventual peak in 1994, but went down in 1999 due to lower emission practices, presumably. From 2000 to present, we'll see an increase mostly in lead and zinc, but decrease after 2010. Leaded gasoline was banned in 2000, but regardless of that fact, lead still went up in the sediments. What they found is on average, 15.9% of the toxic metal is anthropogenic, meaning it comes from humans, and 84.1% is natural. Overall increase in toxic metals such as lead over time, but yeah, most of it was not from humans, even if the levels corresponded with human activity in the area at the time. And this is from heavy metals and lead isotopes in a marine sediment core record environmental changes and anthropogenic activities in the Pearl River Delta over a century. Shisui et al. Now let's go to Beppu Bay. In Beppu Bay, located in western southwest Japan, scientists took marine sediment cores, which included dinoflagellate cysts and paleomorphs, which I know it sounds crazy, but they're just the remains of tiny oceanic creatures and pretty cute actually. And they took them to undergo stratigraphic cluster analysis. It was revealed that eutrophication was happening rapidly in Beppu Bay. Eutrophication is basically when nutrients get like an excess of nutrients get dissolved in the water, and it's responsible for algal blooms, but it gets rid of a lot of the oxygen in the water, which leads it's almost impossible for life to survive in those areas. So eutrophication was happening rapidly in Beppu Bay, starting in the 1960s, more specifically, around the time from 1964 through 1969. And this is attributed to anthropogenic changes such as tidal flat reclamation, overall urbanization, and industrialization in the area. This has been the most dramatic change Beppu Bay has seen in the past 1,000 years. Marine environmental change induced by, and yeah, this is from marine environmental change induced by anthropogenic activities from a viewpoint of aquatic paleonomorph assemblages preserved in sediment cores of Beppu Bay, West Japan, by Kazumi Matsuoka et al. And the image here is an aerial view of Beppu Bay where the sediment samples were collected. Credit 2022 Yokoyama et al. Conclusion. Marine sediment cores can tell us the history of Earth and even the history of humans, even if it was just confirming facts we already know. I find it pretty cool how you can learn so much from what is essentially just a tube of dirt extracted from the bottom of a body of water. The cores in the Pearl River estuary show us an increase of toxic metals in the water over time, most of which coming from natural, non-anthropogenic causes. The cores from Beppu Bay show us the start of eutrophication in the bay starting from the 1960s, coming from the anthropogenic changes in the area. If we keep taking marine sediment cores, who knows what we could uncover in the future. This paleoproxy method can show us what is essentially a logbook from the past. And this image is from Oregon State University. It's titled Sediment Core. Bibliography. Thank you.